Now that we have the error handling squared away, it's time to fill in this last to-do item to do the actual countdown. So as a review, to call a method, I know that I need to put the method name, and this is my countdown method. My countdown method takes one parameter because it needs to know what the number is to start counting down from. So that means that down here, I've got to call countdown using the name of the method, and then in the parentheses I will put the number that it uses. The only number I have available is the user's number, so I'm going to type in usernum. It's completely fine that this is named usernum and this is named startnum. That's fine. The value from usernum will flow into startnum. Okay, so this will call countdown. If I wanted to just test myself, like sanity check here, let me just print out the actual number. And then we'll just make sure that that method call part works. 10, and it prints out a 10. Okay, super. Now the counting down part. This comes directly from the textbook, so you can look at their description of what's happening if my description is not working for you, and for your understanding. So recursion. Recursion means that this countdown method, if it's recursive, will call itself. It makes a call to itself. So what does that mean? In main, I make a call to countdown and I pass a number. So in countdown, if it's recursive, I will make a call to countdown, and just by saying countdown. It's kind of weird that I'm in countdown, I'm calling myself, but it's sort of like, going into a room, opening up a trap door, and then seeing through that trap door an exact copy of the room in there. And then you can sort of dive down that trap door and open another trap door into the next copy of yourself. So this is how I usually think about recursion if it were to happen in real life, which of course is not possible. Now, if I call countdown, it takes a number, so I have to pass one. Here's trouble. Let's see what trouble this is. Hopefully this won't crash my machine. So I'm just going to call countdown with my number. This is sort of going to crash my machine, but hopefully not too badly. Okay, 9. Ah! Okay, so fortunately my computer halted it, but look what happened before all this crazy error messages. I can't even get up there, there's so many error messages. Look, it printed 9 over and over and over and over until I finally started getting the message somewhere here. Some kind of problem. Oh, there it is. Stack Overflow error. Ooh, welcome to the moment where you realize what stackoverflow.com is referring to. So a stack in any programming on your computer is how the computer is keeping track of where your code is. And this is opening so many trapdoors for the different copies of the countdown method every time it calls itself, that all of a sudden it's run out of memory. Ah, this is what a Stack Overflow is. And you have called methods and methods and called methods from methods until the stack is full. So the problem with this recursive method, as printed here, is that there's no way for it to end. And so the first important lesson, and probably the most important of recursion, lesson of recursion, base case, number 1 thing from recursion. You need a base case. A base case is when the recursion stops. So this would be a case where it doesn't call itself, it stops. And in our case, it's going to stop when we get down to 0 because we're supposed to print blast off. So let's make that case happen right now. If startnum is equal to 0, then print blast off. There. Now, this is completely moot if I go ahead and do the recursive call afterwards, so I need to make sure that the two cases are separate from each other. So the reason the only way they can be separate is if I put an else here, so that this will only happen if this one did not happen. Okay, So my two things, number one recursion lesson, you need a base case. Number two recursion lesson, you need a recursive call. Or other cases that are not the base case. Okay, so I'm halfway there now, but let's see what's going to happen. So in this case, I'll come in with, say, a 9, and a 9 is not equal to 0, so I will go down to the else. I will print out the 9, and I will count down with 9. And then I come back up here, and start number is still 9, and I do the same thing again. And then I come back up here, and the start number is still 9. So you can see I still have the same problem because my number is never changing. So number 2a, and then I think we are done with recursion rules, is something needs to change when you make the recursive call. It doesn't necessarily have to change in the parameter, but there has to be some way for the state of the world to change. In this case, I want to print out the next lowest number, so I will subtract 1. But if I didn't do this, I would have the same problem that I had before. Build. That's more like it. 98765421, then it reaches 0, and it hits the blast off case, and then I am done. So this is a perfect example of a recursive setup. We'll do some tracing with recursion later, but this is the basic idea. In the next example, we're going to use repeated divving and modding in order to pop digits off the end of a number and reverse a number, which is another classic recursive example.